Look at your hands. Look around you. In your room, it is likely quiet. Objects sit in their places. The walls are motionless. Your body feels the peace and static stability of the chair beneath you. This is the most convincing illusion nature has ever created, because in reality, static does not exist. Right now, as I speak this sentence, you are hurtling through the icy void at a speed that would stop the heart of any fighter pilot. 230 kilometers per second. Let me repeat that. 230 kilometers every single second. From the moment you pressed play on this video, you have traveled the distance from London to New York. And the scariest part of this fact isn't the speed. The scariest part is that you will never return to the point in space where you started. We are flying in a spiral, corkscrewing into the blackness of space, trapped on the surface of a rock that spins around a burning star. And that star, in turn, is just one of 400 billion other stars, chained by gravity to a single center. We call this giant stellar whirlpool the Milky Way. It is our home, our island in an ocean of entropy. But here is the irony. We know what galaxies look like millions of light years away. We have seen the spirals of Andromeda. We have seen the flares in the Whirlpool galaxy. We have detailed maps of objects whose light has been traveling to us since the time of the dinosaurs. But we do not have a single real photograph of the Milky Way. Think about that. Every picture of our galaxy you have seen in textbooks, on the internet, or in documentaries is a drawing. It is computer graphics. It is an artist's impression. We have never seen our home from the outside. We cannot fly out beyond its borders to take a selfie. The distances are too monstrous. Even if we launched a camera at the speed of light right now, it would take tens of thousands of years just to exit the stellar disk and turn around. We are locked inside. Imagine you were born in a vast palace, but you are chained to a chair in a single room in the basement. You have no windows. You have never seen the facade of the building. You don't know how many floors it has. You don't know if it has towers or domes. All you have is a keyhole through which a dim light shines. And from this single beam of light, you must reconstruct the blueprint of the entire castle to understand its true size and to learn what monsters hide in the other rooms. For centuries, humanity looked at the night sky and saw only a glowing band. A milky river spilled across the dome of the night. The ancient Greeks thought it was the milk of the goddess Hera. Other cultures saw it as a road for spirits. No one understood the scale. No one knew that this band was the edge of a giant disk into which we are embedded. We were blind. We lived with the certainty that our room in the basement was the entire world, that there was nothing beyond its walls. But humans are creatures obsessed with maps. If we cannot see the territory, we begin to calculate it. We started counting stars. We started measuring angles. We tried to feel out the walls of our prison in total darkness. And the first map we drew turned out to be fatally wrong. This mistake comforted us for hundreds of years. It stated that we were at the center of everything, but it was only an illusion created by cosmic dust. Let's go back to 1785, England. William Herschel, a great astronomer and musician, stands in his garden. Before him is a giant telescope he built with his own hands. His goal is ambitious to the point of madness. He wants to draw a map of the universe. Herschel's method was simple and elegant. He called it star gauging. He pointed his telescope at different parts of the sky and simply counted the number of stars that fell into the lens. The logic was ironclad. If there are many stars in one direction, the universe extends far in that direction. If there are few stars, the edge is close. Herschel spent thousands of nights freezing at the eyepiece, counting glowing dots. And when he plotted the results on paper, a strange picture emerged. He got a flattened blob, shaped like an amoeba. But the most surprising thing wasn't the shape. The most surprising thing was where the sun was. According to Herschel's data, our solar system was located almost in the exact center of this blob, in the very heart of the galaxy. 100 years later, in the early 20th century, the Dutch astronomer Jacobus Kapteyn refined these data. He used photography, a new technology of the time. His model, known as the Kapteyn universe, was more detailed, but the conclusion remained the same. The sun is in the center. The stars thin out at the edges. We are the main characters of this play. It was so pleasing to the human ego. First, Copernicus kicked us out of the center of the solar system, saying we orbit the sun. But now astronomers were essentially apologizing, saying, okay, Earth isn't in the center, but the sun itself is the king of the entire galaxy. The model seemed perfect. The math added up. Observations confirmed the theory. There was just one problem. Herschel, Captain, and every astronomer of that era were victims of a grand optical illusion. Imagine you are standing in a dense forest on a foggy day. You look north and see 5 trees, after which the fog becomes a solid white wall. You look south, and there are also 5 trees. West, 5. East, 5. What conclusion do you draw if you are a logical person but don't know about the fog? You decide that you are standing in the exact geometric center of a circular forest with a radius of 5 trees. But this is a lie. The forest might stretch for hundreds of kilometers to the north and only 10 meters to the south. You don't see the edge of the forest. You see the edge of your visibility. In space, the role of fog is played by dust. The interstellar medium is not a perfect vacuum. It is filled with microscopic particles of carbon and silicon. This is cosmic smog, dust from dead stars, ash from ancient explosions. For our eyes, this dust acts as a filter. It absorbs visible light. The farther a star is, the more dust lies in the path of its rays, and the dimmer it appears, until it vanishes from sight completely. Herschel and Kapteyn thought they were seeing the edge of the universe. In reality, they were only seeing the walls of their room covered in grime. They were looking through dirty glass and thought the world outside ended simply because they stopped seeing it. Because of this dust, they were monstrously wrong about the scale. They believed the Milky Way was a cozy little island, perhaps 30,000 light-years in diameter, a small, understandable, domestic world. They didn't know that a monster was hiding behind the wall of dust. The real Milky Way was many times larger than they could imagine, and we were nowhere near the center. We were in the boondocks, in a suburb of the galaxy. But to understand this, we needed someone who could learn to see through the fog. Someone who would find a lighthouse whose beam could pierce any darkness. That person became a woman who wasn't even allowed to look through the telescope. Her job was to be a human computer. But it was she who found the key to the true size of our cell. In the early 20th century, astronomy wasn't done in observatories under the starry sky, but in dusty offices piled high with glass photographic plates. At the Harvard Observatory, there was a group of women known as computers. They were paid pennies, barred from the telescopes, and their task was to perform routine labor, cataloging thousands of stars on black and white images. Boring, monotonous work that male astronomers considered beneath them. Among these women was Henrietta Swan Leavitt. She was deaf, incredibly meticulous, and possessed a gift for seeing patterns where others saw only chaos. Henrietta studied a strange class of stars, Cepheids. These stars didn't just shine, they pulsed. They grew brighter, dimmer, then brighter again, like a lighthouse slowly rotating its lamp. Leavitt noticed a pattern that changed everything. The brighter the star, the slower it pulsed. It was like a heartbeat. A tiny mouse has a fast heart rate. A giant whale's heart beats slowly. This discovery gave humanity a standard candle. Imagine seeing a light in the night. It could be a powerful searchlight 10 kilometers away, or it could be a dim firefly right in front of your nose. In the dark, you can't tell the difference. But if you know for a fact that it is a 100-watt light bulb, then by its dimness, you can perfectly calculate the distance to it. Henrietta Leavitt gave us this 100-watt bulb. Now, by finding a blinking star, we could know exactly how far away it was. The first to use this tool was Harlow Shapley. But he didn't turn his gaze to individual stars, but to globular clusters, giant swarms of hundreds of thousands of ancient stars that hang above and below the disk of our galaxy, like flies over a dinner plate. Shapley reasoned, these clusters must orbit the center of gravity of the galaxy. If the sun is in the center, The clusters should be scattered evenly around us. But when he measured the distances, he saw something frightening. Most of the clusters were bunched up in one part of the sky, in the constellation Sagittarius. This meant only one thing: the center is over there. Shapley realized we are not kings on a throne. We are provincials. The solar system races along an orbit somewhere in the backyard, tens of thousands of light years from the shining center of the metropolis. The Milky Way instantly grew in size. From a cozy room, it transformed into a giant continent 100,000 light years wide. But one final question remained, the most important one. What lies beyond this continent? At that time, many believed the Milky Way was the entire universe, that beyond its borders lay only infinite void, and those spiral smudges seen in telescopes were just small gas clouds inside our system. The debate was settled by Edwin Hubble in 1923. He pointed the most powerful telescope in the world at the Andromeda Nebula. He was looking for Leavitt's pulsing stars, and he found one. On the famous photographic plate, he crossed out an old mark and wrote in red ink, VAR, variable. Hubble counted the pulse. He applied Leavitt's formula, and he got a result that the mind struggled to accept. The star wasn't thousands of light years away, it was millions. It couldn't be a gas cloud inside the Milky Way. It was another island, another galaxy as huge as ours, but monstrously far away. In a single night, the universe exploded. The boundaries of the world expanded to unimaginable limits. We realized that the Milky Way is not the whole world. It is just one grain of sand on a beach. But it was this discovery that forced us to look at our own home in a new way. If we see spirals in our neighbors, does that mean we live in a spiral too? We began to guess what our body looks like. We understood where we were. We understood we weren't special, but we had no idea how strange and complex this organism actually is. Now that we knew our place, we could start drawing a real map. And what emerged on paper didn't look like a calm disk. It was a structure full of scars, fractures, and invisible forces. Now that we have broken down the walls of our prison, let's look at it from the outside. If you could fly 1,000,000 light years up and look down, you would see the most beautiful sight in nature. A giant shining hurricane, a spiral frozen in time. The Milky Way is a disk, but it isn't thick like a dinner plate. It is thin, incredibly thin. The ratio of its thickness to its diameter is the same as that of a sheet of A4 paper. If you looked at the galaxy edge-on, you would see the thinnest glowing line with a bulge in the middle. This bulge is the galactic core, a dense knot of old yellow and red stars. It's crowded there. It's hot. Stars careen at insane speeds, colliding and grinding against each other. This is the Old City, the historic center that remembers the birth of the universe. And around it, in the absolute silence of the vacuum, the arms are spread out. The Perseus arm, the Centaurus arm, the Cygnus arm. These are not solid structures. They are density waves. They are cosmic traffic jams. Gas and dust compress in these arms, birthing new stars. That's why they glow blue, the color of young, hot giants that live bright and die young. And where are we? We aren't in the center. We aren't even in a major arm. We live in the suburbs, in a quiet backwater that astronomers call the Orion Arm or Orion Spur. It is a bridge, a connector between two giant spiral branches. We live in a galactic village, and this saved our lives. In the densely populated arms, there is too much radiation, too many supernovae explosions. But here, in the quiet, our sun had 4 billion years of peace to grow life. But the word peace is deceptive. The problem with the human brain is that we don't know how to work with big numbers. We hear 100,000 light years across. We nod our heads, but we don't understand what it means. Let me break your sense of scale. Imagine we shrunk the entire Milky Way down to the size of the United States of America. From New York to Los Angeles. This entire colossal disk now fits on one continent. How big do you think Earth would be on this map? You wouldn't see Earth even under the most powerful microscope. It would be smaller than an atom. And our Sun? A giant star that fits 1,000,000 Earths inside it. On a map the size of the USA, our Sun would be a microscopic speck of dust, smaller than a grain of flour. And where is the nearest star to us, Proxima Centauri? On this map, it would be another speck of dust, and the distance between them would be about 200 meters. Imagine that. The entire map is thousands of kilometers, and the two closest stars are two specks of dust dropped 2 football fields away from each other, and everything else between them is void. That is what a galaxy is. It is emptiness, occasionally sprinkled with dust. When you look at a photo of the Milky Way, it seems like a solid glow, but that is an illusion of distance. In reality, it is a desert whose scale breaks the human psyche. And yet, this desert has weight. The visible disk is just the tip of the iceberg. Our entire galaxy is submerged in a vast invisible sphere, the dark matter halo. It extends far beyond the visible stars. It is the scaffolding that holds the whole building together, preventing it from flying apart from the speed of rotation. We live inside a massive, invisible bubble and see only tiny lights floating in its center. But every great city, every complex structure, has a heart, a point around which everything revolves, a place where the laws of physics go mad and space and time twist into a knot. For a long time, we couldn't understand why stars in the center of the galaxy behaved so strangely. They danced around nothing. They accelerated to incredible speeds, whipping around an invisible point, and flew away like frightened beasts. We looked at that point with radio telescopes, and what we found made us shudder. In the very heart of our home, in the center of that beautiful spiral, lives a monster. It has slept for billions of years, but it is still hungry. Let's take a journey. We leave the quiet backwater of the Orion Arm and head for the center. Flying 26,000 light-years, we notice the environment changing. It's getting crowded. The night sky here isn't black, it's burning. Stars hang so close to each other that if you lived on a planet in this region, you could read a book at night by starlight alone. But in the very epicenter of this shining chaos, there is a zone of absolute darkness, a radio source astronomers named Sagittarius A. For a long time, we couldn't figure out what it was. Dust hides the center from optical telescopes. We were blind. But in the 90s, 2 groups of astronomers decided not to look at the object itself, but to look at what was happening around it. They chose a group of stars in the very center and began tracking their movement. Year after year. Decade after decade. What they saw looked like magic. Imagine watching a dance floor in the dark. You see glowing bracelets on the dancers' arms. One of them races in an arc and then sharply, as if hitting an invisible pole, spins 180 degrees and flies back. Nothing in the void can force a star to perform such a pirouette. A star codenamed S2 accelerated to a speed of 25 million kilometers per hour. Something grabbed this giant star by the scruff of the neck, threw it around itself, and flung it away. To create such a gravitational slingshot, the object in the center must possess a mass that defies comprehension. And this is where our brain finally breaks. Imagine an object that weighs as much as 4 million of our suns. 4 million scorching balls compressed into a single point. Now imagine you packed all that mass into a sphere that fits inside the orbit of Mercury. This is Sagittarius A, a supermassive black hole. It's not just a heavy object. It is a hole in the fabric of reality. It is a place where gravity is so strong that it breaks the very concept of place. Light falling in never returns. Time stops there. If you fell in, you would see the entire history of the universe flash before your eyes in a fraction of a second while you are torn into atoms. We call it a monster, but right now it is sleeping. Our black hole is on a strict diet. It has almost nothing to eat except rare gas clouds, so it is relatively quiet. But it wasn't always this way. We see echoes of its past meals. Giant bubbles of radiation, called Fermi bubbles, stretch for thousands of light-years above and below the galactic disk. This is the monster's burp. traces of times when it swallowed stars whole, spitting out energy capable of sterilizing entire sectors of space. In 2022, we finally did the impossible. The Event Horizon Telescope, combining dishes all over Earth, captured the first image of the shadow of Sagittarius A. We saw a reddish ring. That isn't the hole itself. That is the death scream of matter. Superheated gas swirling on the edge of the abyss a moment before vanishing forever. We orbit this monster. It is the gravitational anchor that holds our galaxy together. It is our creator and our potential destroyer. But however scary this dark lord in the center may be, we at least know where he is. We see his shadow. The real horror comes from what we cannot see. On the opposite side of the sky, there is a region that has driven astronomers mad for centuries. Something grand is happening there. Something is pulling our entire galaxy, including the black hole, toward itself with monstrous force. But we have no idea what it is, because our own home blocks our view. Astronomers call this place the zone of avoidance. And this is perhaps the greatest irony in astrophysics. We can see galaxies at the edge of the universe, but we cannot see what is right under our nose, dragging us to the slaughter. Humans have a blind spot in the eye, the place where the optic nerve exits the retina. Your brain simply paints over the picture, filling the void with fiction so you don't notice the hole in your perception. Humanity has a blind spot too, but it is much larger. Imagine you are an astronomer. You have telescopes capable of seeing light from the beginning of time. You can spot a galaxy 13 billion light-years away. But if you point your telescope at a certain strip of the sky, you will see nothing. Well, not exactly nothing. You will see a wall. A wall of dust, gas, and billions of stars from our own galaxy. The Milky Way is so dense in its disk that it completely blocks our view of what lies behind it. Astronomers call this sector of the sky the zone of avoidance. It is 20% of the entire sky. 1/5 of the universe is hidden from us by the curtain of our own home. We have no idea what is happening there. Maybe thousands of supernovae are exploding. Maybe there are galaxies full of life. We don't know. And this wouldn't be a problem. So what if we can't see in one direction? Space is big, if not for one frightening fact. In the 1970s, we discovered that our galaxy is moving. Not just rotating, it is flying through space. By measuring the temperature of the cosmic microwave background, the echo of the Big Bang, we realized that space on one side of us is slightly hotter and on the other, colder. This is the Doppler effect. It meant we are hurtling in a specific direction at insane speed. 600 kilometers per second, 2 million kilometers per hour. Something is pulling us. Something so massive that it forces the Milky Way, Andromeda, and dozens of other galaxies to flow toward it like water flows down a drain. We named it the Great Attractor. It is a gravitational anomaly of monstrous power. To create such a pull, there must be something concentrated there equivalent to tens of thousands of galaxies. And here is the climax of cosmic irony. The Great Attractor is located exactly where we cannot look. It hides right behind the center of the Milky Way, in the thickest part of the zone of avoidance. We are racing towards something gigantic. Our entire local group of galaxies is falling into this gravitational pit, and our own home is blocking the windshield. We are passengers in a car with no brakes, with the front windows boarded up. Over the years, using X-ray and radio telescopes that can partially penetrate the dust, we began to make out vague outlines. We found a giant cluster of galaxies there in the constellation Norma. Then, even further, the Shapley supercluster. These are titans, huge concentrations of matter. But even their mass is not enough to explain the speed at which we are flying. There must be something else, something bigger. Some theories say the Great Attractor is just a confluence of cosmic rivers, a knot in the web of dark matter. Others say it is just the antechamber to an even more terrifying structure. But the fact remains, our fate, our vector of movement, is defined by what is hidden from our eyes. We are used to thinking we control the situation. that science gave us sight. But the zone of avoidance reminds us we are still the same people in a dark room trying to understand the world through a keyhole. And someone just blocked the light from the other side. To break through this curtain of the unknown, we needed to stop looking into the distance and finally study the curtain itself in detail. We needed a map of every atom, every star that prevents us from seeing. And for this, we launched into space the most perfect eyes in human history. This project was called Gaia, and what it showed us made us forget about what was outside, because we realized the most interesting things are happening right here, inside. Our galaxy turned out to be alive. In 2013, a Soyuz rocket launched from the Kourou spaceport. It carried a device that looked like a giant magician's hat. This was the Gaia telescope, and its mission was the most ambitious in the history of cartography: to create a 3D map of our home. Before Gaia, we knew precise distances to only a few thousand stars near the Sun. Everything further away remained the realm of guesswork and rough estimates. We built models of the entire galaxy based on a handful of data. Gaia changed the game. This machine doesn't take pretty color photos of nebulas you're used to seeing on NASA's Instagram. It does astrometry. It measures position. To understand the precision of its cameras, imagine you are standing on Earth, and your friend is standing on the Moon holding a coin. Gaia is capable not just of seeing that coin, it is capable of noticing if your friend moves it by 1 single millimeter. Using this inhuman eye, Gaia began scanning the sky, again and again. It tracked the position of nearly 2 billion stars. This isn't just a map, it is a census of galactic scale. When the first data arrived on Earth and supercomputers processed it, astronomers saw the Milky Way as no one had ever seen it before. We didn't see a static picture, we saw motion. Gaia measured the velocities of stars. It showed us where each one is going, and that's when a discovery happened that gave scientists goosebumps. We always imagined the Milky Way as a perfect, flat pancake, a smooth disk that majestically and smoothly rotates around the center, like a vinyl record on a turntable. Gaia's data shattered this ideal. The Milky Way isn't flat, it's warped. Its edges are curled up and down, like the brim of an old hat or a Pringles chip. But that was only half the trouble. When we looked at how the stars in the disk move, we saw ripples. Imagine the surface of a quiet pond. It is smooth, but if you throw a stone into the center, rings will spread across the water. Waves will lift and lower the water. The stars of our galaxy behave exactly the same way. They don't just fly in a circle. They rhythmically rise and fall, compress and spread out. Our galaxy is trembling. It is vibrating. It looks like the membrane of a giant drum that someone has struck. And judging by the nature of the waves, this strike happened relatively recently. By cosmic standards, of course. The sound of this impact still echoes through the spiral arms, causing billions of stars, including our Sun, to bob on invisible waves. This discovery turned astronomy into a crime scene. Who could have hit the galaxy? What possesses such mass and audacity to shake a structure weighing 1.5 trillion solar masses? Gaia gave the answer to this question too. It allowed us to rewind time. Analyzing the trajectories of millions of stars, we found outsiders. Stars that orbit differently from everyone else. Stars with a different chemical composition. These were debris, evidence, traces of an ancient and brutal feast. It turned out that the Milky Way is not a peaceful city. It is a graveyard built on the bones of the conquered. We found the culprit of the tremor, and we understood the terrible truth about our origin. We didn't get big because we just grew. We got big because we ate others. When astronomers sorted the Gaia data, they noticed a group of stars behaving like ghosts. They moved in elongated, strange orbits, piercing the galaxy's disk through and through. And most importantly, their chemical composition was different. They had fewer heavy elements than our native stars. These were not locals. These were the remains of an eaten victim. Astronomers named this structure Gaia Enceladus, or less poetically, the Gaia sausage, because of the shape these stars form on velocity graphs. About 10 billion years ago, when the Milky Way was still young, it collided with another galaxy. It wasn't small, about the size of the small Magellanic Cloud, but it didn't have a chance. Our galaxy's gravity grabbed it, tore it apart, and consumed it. The cores of the two galaxies merged, heating up gas and triggering a frantic burst of new star birth. Perhaps it was this cataclysm that created the conditions for the formation of our Sun billions of years later. We are children of catastrophe. Our galaxy grew by devouring its neighbors. But these are not deeds of days long past. Look at the sky of the southern hemisphere. There you can see two misty patches, the large and small Magellanic Clouds. These are satellite galaxies. They dance around us, and they are doomed. We are stripping gas from them. Right now, a giant tail of gas stretches from the Magellanic Clouds to the Milky Way, called the Magellanic Stream. We are drinking their blood, depriving them of fuel for new stars. Eventually, they will fall into us and dissolve, becoming part of the empire. But the most dramatic act of cannibalism is happening right now as we speak. Remember that disk tremor? Those waves on the pond we talked about in the last section. The culprit has been found. It is the Sagittarius Dwarf Galaxy. This is a tiny galaxy by cosmic standards that had the misfortune of flying too close. It first crashed into our disk a few billion years ago. The Milky Way's gravity stripped away its outer layers, but it survived. It did a loop, turned around, and crashed into us again, and again, and again. Every time, punching through our disk like a bullet through a target, it lost stars and mass, and every impact sent those waves of ripples throughout the Milky Way, making our structure vibrate. Now, only a pitiful core remains. Long ribbons of its stars, torn out by our gravity, are wrapped around the Milky Way like spaghetti around a fork. Astronomers call these stellar streams. It sounds beautiful, but in essence, these are the guts of a torn-apart galaxy put on display. We live inside a predator. The Milky Way is not a static painting. It is a maelstrom of violence. We pull in everything that flies by. We tear dwarf galaxies apart with tidal forces, turning them into long threads, and appropriate their stars for ourselves. Our entire history is a history of consumption. We became big and beautiful because we were the hungriest thing in this sector of space. We are used to thinking of ourselves as the top of the food chain. We look at dwarf galaxies like a lion looks at antelopes. But in the universe, there is always a bigger fish. While we are busy digesting our small neighbors, from the depths of space, an eye larger than ours is watching us. It has been watching us for billions of years. And all this time, it has been getting closer. The Milky Way is a killer, but soon the killer will become the victim. 2.5 million light-years away from us lies the Andromeda Galaxy, and it is flying straight at us. This is not a probability. This is an inevitability written into the laws of gravity. Go outside on an autumn night and find the constellation Andromeda. If you have good eyesight and the sky is dark enough, you will see a small, dim smudge. It looks like a torn-off piece of cloud. This light left its source 2.5 million years ago, when human ancestors were just learning to make stone hand axes. This is our great neighbor, the Andromeda Galaxy, or M31. It is bigger than us. It has 1 trillion stars, and every second you look at it, it gets 110 kilometers closer. We are used to thinking that space is static, and this event is a matter of the distant future. Textbooks say the collision will happen in 4 billion years. It seems infinitely long. But here is a fact that forces a rethink of the very concept of future. In 2020, the Hubble Space Telescope mapped the gaseous halo of Andromeda, that same invisible atmosphere that surrounds galaxies. It turned out to extend much further than we thought, 1 million light-years in every direction. If our eyes could see this gas, Andromeda wouldn't be a small smudge. It would occupy an area on the night sky the width of 6 full moons. And our latest data suggests that the halo of the Milky Way and the halo of Andromeda have already begun to mix. Technically, the collision has already begun. We are already breathing the same air. The first atoms of the outer shells have already struck each other in the cosmic silence. But the real show is yet to come, and it will be the most beautiful spectacle this part of the universe has ever seen. If we could place a camera on Earth and hit fast forward billions of years into the future, the night sky would change beyond recognition. First, Andromeda will become huge. It will stop being a smudge and turn into a giant disk, rivaling the Milky Way in brightness. The two spirals will begin to warp, stretching out toward each other like the arms of dancers. Gravity will start tearing stars from their orbits. The band of our Milky Way, which we see now, will be torn apart. The sky will turn into a chaos of glowing arcs and streams. At the moment the galaxies pass through each other, the sky will burst into fire. Gas clouds will collide, compressing and birthing millions of new bright stars simultaneously. It will be fireworks on a galactic scale. But here is a paradox. Despite the scale of the catastrophe, the probability that our sun will physically collide with another star is practically zero. Stars are separated by such vast emptiness that the galaxies will pass through each other like two swarms of bees, or like two ghosts. We won't crash, we'll just change our address. The solar system might be thrown far out to the outskirts into the cold void, or conversely, hurled toward the center. After the first pass, the galaxies will fly apart, break, turn around, and fall into each other again. This dance of death will last another couple of billion years. In the end, the two spirals will merge into one. The beautiful arms will disappear. The chaos will settle. A new giant elliptical galaxy will be born. Astronomers have already given it a name, Milky. In the center of this new world, two supermassive monsters, our black hole and Andromeda's black hole, will begin to spiral closer, until, in a final chord, they merge into one object of monstrous mass, unleashing a gravitational wave that will shake the very fabric of spacetime. By that time, Earth will have long since burned, destroyed by the expanding sun. But the atoms that make up your hands, your eyes, this screen, they will all be there. They will become part of a new, huge, dimly glowing orb. The history of the Milky Way will end. The history of Andromeda will end. The history of something greater will begin. And there is a strange comfort in this. We are not eternal. Our home is not eternal. Even stars are not eternal. Everything flows, everything changes, merges, and is reborn. But even Milky is just a dot on the map. If we take a step back even further, we will see that even this titanic merger is just a ripple in a much greater ocean. Because both the Milky Way and Andromeda are just tiny fireflies drifting in the current of a great celestial river. The name of this river is Laniakea. If we continue to zoom out further and further, even the future giant Milky will turn into a dot. It will become just one of 100,000 other dots, glowing motes of dust connected by invisible threads of gravity into a colossal structure. We call this structure Laniakea. In Hawaiian, it means immeasurable heavens. This is our true nation, a supercluster of galaxies 500 million light-years wide. Here, at the scale of Laniakea, galaxies no longer look like islands. They look like streams. They flow like glowing rivers along the fibers of the cosmic web, draining into valleys of gravity. And somewhere there, on the periphery of one of these thinnest fibers, flies our Milky Way. At the beginning of this journey, we talked about being trapped, that we are prisoners in a basement who have never seen our house from the outside. We talked about the fear of black holes and what is hidden in the zone of avoidance. But look at it from the other side. We are creatures less than 2 meters tall. We live on a speck of dust orbiting a spark. Our brain is just 1.5 kilograms of wet matter. And yet, without leaving our room, we were able to draw a map of all of this. We were able to see the invisible. We were able to weigh monsters that could swallow our system whole. We were able to predict our own demise in 4 billion years and accept it with awe, not fear. We finally learned how big our home is. And this size should not frighten us. It should liberate us. Yes, we are small, but we are the part of the universe that has gained consciousness. We are the eyes through which the cosmos looks at itself. Right now, you are still sitting in your chair. Around you is still the same room. But now you know the truth. The walls are an illusion. The peace is an illusion. You are a traveler aboard the most beautiful ship in the universe. You are flying through the Orion Arm, orbiting Sagittarius A, falling toward the Great Attractor, drifting in the current of Laniakea. The journey continues, and it is only just beginning. Thank you for joining me on this flight, and don't forget to look up sometimes. There, in the dark, is our real home.